This micro-credential deals with network planning and design and consists of 5 targeted skills. This targeted skill is about digital subscriber lines DSL. When the Internet was first developed, a technology was needed to provide access to as many households as possible. Almost every household had a phone line going to it. The easiest solution was to send data streams across the already existing media. These dial-up telephone networks were not designed for digital transmissions. Therefore, the data had to be converted prior to being transmitted. Transmission rates with this technology topped out at 58 kilobits per second, kbps. As content size increased, faster transmission alternatives needed to be developed. Digital subscriber lines, DSL technology, was developed to allow for faster, dedicated digital data transmission over existing phone lines. Because DSL is digital and traditional phone service is analog, both conversations can travel across the same media without interfering with each other. However, splitters may be needed for DSL to operate at higher speeds. For slower speeds, a DSL modem was used to separate out the data stream, converting it to a type of signal used by a computer. Filters are installed on the analog phones to remove any noise caused by the digital data stream. Each DSL subscriber has a direct connection to the telephone service provider's central office. The telephone company combines these connections using a device called a DSLAM, DSL Access Multiplexer, to connect the customers to the Internet. There are 2 main types of DSL: asymmetric DSL, ADSL, and symmetric DSL, SDSL. ADSL is the most common and most affordable for home installations. ADSL provides greater bandwidth for downloading from the Internet than for uploading to the Internet. By reducing the amount of bandwidth used for upstream traffic, there is more bandwidth available for downloads. There are several different types of ADSL. They vary in speeds from 1 to 100 megabits per second, Mbps, for downloads, and from 384 kilobits per second to 2.3 megabits per second for uploads. Not all types of ADSL may be available from all providers, and the speeds are the maximum as opposed to what are guaranteed. By comparison, SDSL connections have equal bandwidth for download and upload. They are typically used by businesses that may be using cloud storage for backups or have remote users using virtual private networks, VPNs, and need greater requirements for transferring data. SDSL supports speeds up to 15 megabits per second. DSL suffers from 2 serious problems that limit the speeds available to customers. The first problem is the underlying technology that carries the signals. The quality of the lines and the equipment carrying these signals varies widely due to when they were installed and how they were maintained. Corroded or loose connections, damaged shielding, and interference sources all contribute to noise that can reduce data transmission rates. The second problem comes from attenuation. It is caused by resistance to the flow of electrons called current through the copper media. That attenuation results in loss of signal strength. Think of the water waves generated when a pebble is thrown into a pond. As the waves spread across the water, they lose strength as they move away from the center. The same is true for a customer. The further a customer is from the central office or the source, the weaker the signal. That translates to less bandwidth being available to that customer. This is why DSL has a maximum distance from the central office of 18,000 feet. The further away a customer is from the source, the slower the download speed. While dial-up and DSL both filled a need, newer technologies are now available that provide greater bandwidth and higher reliability. Because of this, DSL should only be considered if the customer is on a tight budget or if there are no other alternatives in the customer's home area.